I got a few questions in, kind of four people kind of asked me the same question in this last month, which is quite interesting, about repeated sprintability and NIRS and kind of what NIRS is telling you about repeated sprintability. And I thought I would highlight two papers that talk about this and talk about it practically a bit. So the one paper is pretty new from last year from Vasquez and colleagues, and they did repeated sprints with soccer players, I believe, and the other one's by Jones, which is an older paper. I'm not quite sure what year now, but a little whiles back. And they did it with field hockey players, but they did interesting. They did like an intervention, like a pre-post, so with the training intervention, doing repeated sprint training, whereas the other one was just kind of a 1 point study, just a point in time, so a cross-sectional study. So I'm going to talk about the Vasquez study first, and kind of what they highlight, and then talk about the Jones study as an interventional study to see how things change with sprint interval training. So in the Vasquez study, look at some images here, some figures that they put out of the example data set that they had, and then we'll look at some analysis. So what they're doing here is that they have repeated sprints. So you have decreases in muscle oxygenation, and then with recovery periods, increase and decrease and increases that we see here. And we get this general tendency, which is what we also see when we do this with athletes, is you kind of have this general slope upwards. If you kind of draw linear, if you draw just a linear function across it, you have a general increase of muscle oxygenation overall. And this is something Vasquez also highlights. So where they kind of identify a hyperemic effect as being the cause of this. So I'm going to pull up here just quickly a quote, just so that we kind of get Vasquez's own words for this, and they kind of highlight or make these 2 points here. Where they say, the study demonstrated that there's a gradual increase in SMO2 observed in all repeated sprintability tests. So this is what we talk about, right? This general trend up, right? And they're highlighting this as a performance limiting factor in maintaining high speed during repeated sprintability. So this fact that this trend kind of goes upwards is somehow limiting performance. So sure, why not? I agree with this. Performance is decreasing as you kind of move on the number of sprints that you're doing, and you're seeing that this trend is happening. So there's something there. The second point is more interesting. So the desaturation and resaturation of the slopes, which I think is very important. This is something that we talk about often, is the rate of resaturation, desaturation, kind of the dynamics of your near signal. And so they have, so what they say is the desaturation and resaturation slopes are dependent on fatigue caused by high speed during repeated sprint exercise. So now that there's the link there, I agree. I'm not sure if I would word it like this. So I would probably word it the other way. Fatigue is dependent on desaturation and resaturation. So this is always kind of a little chicken and the egg thing. A physiologist, so in my opinion, the physiology dictates the performance. You have the engine is doing something, and then you get the speed of the car, right? It's produced by the engine, and not the speed of the car is affecting the output of the engine. That's the way that I would look at this. It doesn't matter that much. The point here is that the desaturation and resaturation slopes are relevant for performance and are somehow related to fatigue in repeated sprintability. So I agree with that. And they show this in their analysis. So they show, if we pull up this analysis graph, they show that their worst times are related to desaturation and resaturation rates. Okay, so somehow the ability to use oxygen or the lack of supply, let's say it's always, again, supply and demand, but the rate of change in desaturation and resaturation are somehow linked to the ability to complete a sprint in repeated sprintability. And they show pretty nice correlations here for this. So this is something that we also observed. But what's interesting here, what they kind of point out, which they point out quite nicely in a way that I haven't seen seen before, even though it's often stated, maybe not directly, but they make this new parameter and they call it's SMO2 del, which is like it's like an upside down delta. And this is it's the direction and rate of the fastest increase. So basically, it's a parameter that then takes together, so integrates together desaturation and resaturation. So you kind of mix that together to analyze your repeated sprint ability. I'm not going to go too much into that, but I think they're going in a good direction with that. So go look at the study if you want to read about that. I think that probably makes a lot of sense, that it's going to be an interplay between those two that is going to in the end dictate your sprint ability. It's not just your desaturation or your resaturation rate. It's the two together that are going to be relevant. Okay. So having said that, I'm going to move on to this next study, which is the Jones study. And in the Jones study, they actually did an intervention doing repeat sprints. So they took players. I'll show some example data from the study. So this is 6 subjects. So the N value is pretty low here. And they did pre and post repeated sprints. And we see here the post in dark and the pre in light. And generally, what the conclusion was that what happens is you have an increase in delta, so in the absolute change of TSI, so of the oxygenation in the muscle as a percent. Here they're using tissue saturation index, not SMO2. But you have an increase in delta, so you get more desaturation happening post-training. So that delta gets bigger. And what they also show is that the desaturation rate, so the rate of oxygen consumption, increases. Now, they didn't end up getting significance. Again, with an N of 6, it's going to be hard anyways, but it's real close to being significant. I would say that this is, from an effect size point of view, is likely significant considering the small N. But these were the conclusions that Jones and colleagues came up with. So what this means for your repeated sprint ability is there's a couple things we need to look at. We need to look at probably the rates of change being key here. How quickly am I desaturating? And if I'm doing repeated sprints, the ability to desaturate and resaturate is going to dictate how well I'm performing and what the quality of my repeated sprints are going to be. This is somewhat like bar velocity. If people do bar velocity stuff where if you can't maintain velocity and you're doing power training or speed training in your strength work, you often just stop your training. So if you can't maintain the desaturation and resaturation rates, it's likely that you are going to stop your repeated sprints because your quality is going to go down. One of the easier ways to kind of follow this is by identifying things like mins and maxes for recovery and max performance or peak sprint time, and relating those back to time, right? So I'm doing 30-second breaks. How much am I desaturating? How much am I resaturating in the same amount of time? So it's going to help you with kind of grapple with these rate concepts. So kind of identifying those, and then progressing over time. The goal would be that you are able to kind of bring those oxygen values lower. You're able to extract more, which is what the Jones study is showing, right? That the training is resulting in this and improving performance. I hope that helps. It's really, so you can go read these studies. I didn't go too much into the physiology of things, but the studies go into that a lot more. But it's definitely, I think, very useful. Here, NIRS becomes very useful because its ability to provide feedback at a higher rate than, let's say, heart rate, which has often a much higher lag time, or something like lactate, which has a much longer lag time. So this real-time use of the NIRS signal for repeat sprint ability, I think, has quite a bit of value, which both authors identify as well. So I hope that was useful. Thank you very much. Bye.